afternoon, everybody. My name is Abhay, and essentially, this journey for me started about 18 months ago when one of our clients came back to me and said, we are running so many security tests, we're running penetration tests, we're running source code analysis, yet we never seem to fix anything. How many of you have had that problem? You run a bunch of things. You run penetration tests, you run source code analysis, you run, like literally, you throw everything at it. You throw everything at it, and still you always find those critical issues that come up, those high severity issues that come up. Some customer would have found something, or a customer's penetration tester would have found something. You're in trouble, right? And the whole system kind of breaks down after that point. So this really began not just mine, my team's journey into this whole process of security and DevOps, and that's what I'm going to try and bring to the table today. So my name is Abhay. I head a company called V45. So my team and I work with application development houses, could be a corporate or it could be a product company, from the Silicon Valley in the east to the Silicon Valley in the west. So we have a breadth of clients all across the board, and some of these today, what I'm going to be talking about is a bunch of stories from all of these clients that we've worked with, of course, with their confidentiality maintained. So I personally have done a lot of work in this space over the last 18 months, as I said, and some of it has been very exciting. I've got to work with some great tools like OWASP Zap, which really opened up a lot in terms of this entire practice area. A lot of people in this conference have spoken about OWASP Zap. So I'm going to try and bring in a little more under the hood kind of analysis of OWASP Zap. I'm also going to be talking about a tool that somehow people seem to have forgotten about, W3AF. And W3AF is still a very popular tool, still used by several, and very interesting implementation of W3AF is something I'm going to try and bring to the table today. So first of all, I'll quickly make a case for SecDevOps. That is, why do we need security in DevOps? I'm sure all of you have heard of DevOps. I'm sure all of you have probably implemented DevOps or implementing DevOps practices within your own organizations. Now, I'll make a quick case for DevOps and then get into my stories. The first story is about vulnerability scanning junkie. The second story is about a threat model. And the third story is about rapid deployment is equal to vulnerability scale. So let's get started. So can anyone tell me the one line that has ruined application security for everyone? Just one line. Anyone? This line. Right? How many of you have heard of this line from either your product heads or your product managers or your the business managers who head that particular application? They just say, you know what? Let's just test before we go live. Right now, functionality is critical. We need to get the functionality up and running. Once the functionality is up and running, we can test your security well and good. And then, of course, they run a penetration test, and then, of course, they get 150 action points that they need to fix, and then everything goes kaput. Am I right? So this line, in my opinion, has ruined application security for all of us for a very long time. So my first intro to DevOps didn't actually come from the IT industry. It came from a book on manufacturing called The Goal. I don't know how many of you have read The Goal by Eliyahu M. Goldratt. The Goal, or the Theory of Constraints, I'm sure a lot of you might have read it or might have heard of it. That, I believe, is one of the most defining works in the world of DevOps, actually, even though it has nothing to do with DevOps, which is weird because it was written quite a while ago. It was focused on manufacturing. It focused on completely different problems. But the problems in the book and the problems that we face in security and in IT today are very similar. And there is a concept in that book that says you need to increase throughput and simultaneously reduce operating resources. So in our parlance, in application development, increasing throughput meaning delivering applications quicker, better quality applications to clients. This means better UI, better UX, better security, better functionality, et cetera, delivering them as fast as we can. And operating resources essentially refers to the amount of time we take to fix, time we take to develop, time we take to security, perform security testing, perform security bug fixes, all of that stuff. So the objective of the entire premise behind the theory of constraints is obviously increase your throughput while simultaneously reducing operating resources. And that became a very powerful thought that seeded in my head, and that really brought this talk to life. Of course, today, all of this happens, right? We see companies deploying at extremely rapid scale. We've heard legendary stories of Amazon deploying every 11.6 seconds. How many of you have heard of that story? 11.6 seconds is what they claim to deploy. Etsy, by their own admission, in their SlideShare presentation, you can go through Etsy's DevOps practices, and they say they deploy about 25 times a day. Now, even if your app is not in this frame, it's likely that you're doing deployments pretty rapidly. It's likely that you are deploying at scale, and you're doing your CI/CD pipelines at pretty frenetic pace. But today, this is what has happened, right? You have application delivery running at the speed of Usain Bolt, and you have this fat guy, which is application security, trying to eternally catch up to the application delivery. And of course, judging by the size, this guy is not going to make it, right? He's not going to even come close to this guy who is going at miles ahead. So really what really happens is, for instance, you do a pen test on product A on day 1, and by day 10, it's a completely different product, or the product has changed extensively, and application security has no clue how, or no clue why, or no clue as to how to deal with this particular set of changes. So obviously the bottleneck, clearly, what happens is you do your agile, you do all of your requirement analysis, you do your design, development, and then it completely gets blocked because security is failing, or security has already failed. And this has become a very, very pernicious problem in the industry, and that still continues. So let's start with the first story. This is a story of a very large fintech client that we were working with. And this client they had pretty mature DevOps processes, right? They had, they had set up their automated scanners. They had a bunch of them. They'd invested in a bunch of tools. They'd invested in a bunch of SaaS tools and a bunch of DaaS tools. They had a small security team. I mean, it was a small fintech company, so they had a small security team, but they were doing a diligent job of DevOps. But what happened was that as soon as they used to, their customers would insist that their pen testers perform a pen test on their particular platform. And as soon as this happened, their entire process kind of broke down, right? Because the customer pen tester would go in and perform a test, find all kinds of issues, and then come back with a bunch of results. And these guys were like, we're investing so much time, so much effort, so much resources on security, and why aren't we able to fix issues? Why aren't we able to actually find these issues before they go to the customer? So obviously, their biggest problems were that their customer pen tests always came up with critical and high severity issues. They seemed to be missing several issues in every release. Several security issues were slipping through the cracks, right? No unified perspective on vulnerabilities, simply because, for instance, I release a pen test report once a quarter. Now, in fact, even in major regulations like PCI or any other standards, you'd see perform penetration testing or vulnerability scanning once a quarter. Obviously, that doesn't make any sense for most applications, right? And no validation of false positives. So that was a serious problem statement that they had. Obviously, what we felt was that automated vulnerability scanning was great. However, automated vulnerability scanning only finds a few issues. They find some low-hanging fruit, and they don't really get into the depths of it. Now, especially with stuff like, I mean, you can throw anything at it. You can throw Akunetics, you can throw Burp, whatever it is. But automated scanning has its limitations simply because, one, authentication is a challenge for a lot of automated scanners. If you've worked with any, from Zap to Arachne or whatever scanner that you work with, automation, authentication, authorization, all of these complicated logical elements of the application is a problem for most of these scanners. And when it comes to web services, and especially JSON-based payloads, these scanners also tend to falter a little bit, right? Especially when you're talking about standard scanners. They don't seem to read the logic that's going back and forth in the JSON. They don't try and do a lot of payload delivery within the JSON. It does happen, but it's not nearly as good as it should be, right? So, of course, manual pen testing, nobody has time for that, right? Because every time you're developing, you have Scrum sprints, you have rapid release cycles, and manual pen testing, if you run a manual pen test for 3 weeks, your cycle is gone way past, and it's time that you miss the bus, clearly. Now, in my experience, and please correct me if I'm wrong, and the ones in the green are typically found by automated scanners, right? The ones in the green, I'm talking about configuration issues or loosely scoped session tokens and all of that stuff is found. Of course, they do find SQL injections, they do find cross-site scripting, but a little more advanced variants of cross-site scripting and SQL injection, obviously these tools find it difficult to find. And apart from this, the authentication problem is a serious problem. Now, Zap does have an authentication module if you're using its API, but I've somehow found that it's never worked as well for me when I've done it. But a lot of these vulnerabilities, especially if you're talking about insecure direct object references, cryptographic flaws, if you're talking about advanced cross-site scripting issues, CSRF issues, of course, most of these tools detect that a CSRF token is missing or something like that. But if you really want a proof of concept, you really want to do a detailed analysis, CSRF flaws are not there. And of course, if you throw AJAX and web services at these issues, it automatically becomes a lot more complicated, even though they have advanced spidering capabilities today, right? So what we decided to do was come out with a solution with different levels of coverage, right? So the first level of coverage would be obviously to identify the low-hanging fruit. That is to identify what the typical automated scanners would run. In this case was Zap. We also integrated the W3AF REST API. Now, for those who haven't used the W3AF API, I highly recommend it. It's extremely powerful. It can do some great scanning. It can give you some results that many other vulnerability scanners find very difficult to get. I'm going to showcase some of this as well later on. But W3AF's API is pretty neat, and we've used it extensively for a lot of stuff. And of course, we also integrated this with their Nessus and Nikto deployments just to find some of the stuff that we were missing as low-hanging fruit. The other stuff that we did was that every single time we ran a pen test for them, what we did was we scripted these up in Selenium, right? Either Selenium or some other REST testing framework, and loaded it into their particular, either in their Jenkins or into a particular API layer that we'd implemented for them. And this, what it did, was it identified very specific issues, right? Authorization flaws, crypto flaws, session fixation flaws, and it actually gave you a full database of flaws. So by the end of the year, you not only have your L1 coverage, which is the basic stuff, but you also have very, very advanced coverage through your customized flaws. So this is also linked back to their threat model, which I will speak about later, essentially where so for instance, let us say that one of their threat models was that one financial agent should not be able to view the data of another financial agent. And this is obviously an authorization flaw if somebody is able to do this. So one of the things we did was every particular parameter that was passing a financial agent's ID or a parameter value, we tried to fuzz it with different financial agents' IDs and parameter values to see if we were actually able to gain access to their account or elevate privileges to that particular agent's account, so on and so forth. This is just an example, but the point is that our approach was really around figuring out the low-hanging fruit, which gives you a lot of the basic vulnerabilities, a lot of the SQL injections, the cross-site scripting, and some of the other stuff, and go after some of the more complicated business logic flaws like authorization, crypto, all of that stuff. All right, so one of the things we did with Zap was we used a Selenium authentication script. Now Zap has something called a daemon mode, where you can start it off as a daemon, and you can even you can set a proxy. And then what we did was we passed that particular Selenium script to do this particular authentication to this app. So what the Selenium script did was that it would authenticate to the application using Zap as the proxy. And once it authenticated using Zap as the proxy, Zap would start the spidering, Zap would start the scanning, and Zap would start all of that good stuff. So the point is that we are essentially delinking Zap with the authentication part, because in many applications, authentication logic is pretty complex, right? Especially when you have AJAX or when you have web services driven authentication or slightly more complex authentication patterns. The Zap API, what we felt was would not give you that much bang for your buck. So what we did was we wrote a separate script, and this script would authenticate, do a little bit of perform one or two actions which were required for the Zap proxy to capture it, and then Zap would automatically have that cookie value, have all of that authenticated goodness, and take that and perform the spidering and the subsequent scanning. You can run all of Zap's modules against that whole thing. All of this was, of course, the great thing about doing this was that you can do this with any headless browser. For instance, you can use Firefox in a headless way, so you can just start Firefox without any UI, and you can just run this completely headless. You can use Phantom.js, you can use Google Chrome, you can use IE. Now, one thing that we've found, I mean, the reason for doing this is a lot of times different browsers behave differently when it comes to client-side attacks, right? Especially with JavaScript-based attacks, different browsers behave differently, so this gave us a lot of value. So you can run an entire security test suite in IE, and then in Google Chrome and Mozilla, what other browser you would have it. So this really became a very powerful way of finding those low-hanging fruit, finding those vulnerabilities that Zap can do. And of course, the great thing about the Zap API is you can customize your entire scan policy, and that particular scan policy, you can set the thresholds, you can set the entire, what do you call it, the attack strength. They have multiple modes. They have low, medium, high, and insane. So if you want to focus on one bunch of vulnerabilities, you want to test them in insane mode, and the other you want to test them in, or you don't want to test them at all, you can do that with Zap. So that's a great way of actually customizing and playing with Zap's scan policies. So, of course, I'm going to be talking about the Python API, and of course, this is available to all of you who are writing Java code as well. I think Zap has a pretty mature Java API as well. So the zap.spider, the object is held within the Zap call. And then you have zap.spider, which will initiate the spider object, and you can do the scan. You can asynchronously get the status as well. So what we did was that we included a WebSocket front end kind of a thing where Zap was constantly sending it a bunch of results saying, I'm spidering at 20%, 30%, whatever, 40%. So you can actually have a status message coming back on each of these things, right? You have status calls that you can do. .status would give you the status of each of these calls that is performed. So this is the Zap spider plus scan, which would do the spidering and authentication. This would do the passive scan. The P scan in Zap does the passive scan. It performs all the passive scan modes that Zap does. A scan, you can call it with a particular scan policy. I'm going to show you some code. I'm not running a demo simply because the demo would take too much time. I'm just going to show you some of the code, and you can take it from there. Parameters enumerates all the parameters of the results. So when you get the results back, you get all the parameters that are found to be vulnerable, and you get the different gradations of the vulnerabilities as well. You also have the alerts, which essentially are all the active scan and passive scan results, right? Now, if you've used Zap, you'll see that all of the alerts contain the vulnerabilities that have been found, either low, medium, high, info, whatever. You would find all of that in the alerts object. So let me just quickly take you through some of the code. Yeah, so this is the, this is, if you see this, so we've just created an object. I don't know how many of you can see this. We have created an object that is instantiated. It calls the Zap executable, at whenever we need to initiate the scan. It calls the Zap executable, like here, in daemon mode, and it performs, it sets all the proxy values, it runs the spider. Of course, one of the things you must remember is to implement some amount of pauses in between the scan, because Zap takes some time loading up some of these components. So you need to implement some amount of gap between the time these components are initiated. Now, if the object finds an authentication script, it runs that authentication script. Now, this is the authentication script that relates to that particular proxy, right? For instance, let us say you have a custom authentication set for a particular application. You would instantiate this authentication script, pass it through the Zap proxy, and then the authentication would happen, and then Zap would finish up. So I'm going to move on because I have 15 minutes left, and I have a lot of material to cover. But if anyone wants to talk about this a little bit more in detail, please see me after the talk. So once we did this, we generated a report and sent it to the project manager, and on an everyday basis, we also generated some very neat-looking dashboards. Just a small view of that. Now, W3F is a very, it's actually an underrated tool in my opinion. It can do quite a bit of stuff. It has a ton of plugins, and these plugins can find everything from HTTP comments to, you can find credit card data, social security numbers leaking on your application. There is a ton of stuff that W3F can do. And that is very interesting, and we were able, what we did with W3F was slightly different from Zap. Because W3F has a spidering module called Spider-Man. How many of you have used W3F and Spider-Man? Anyone? Now, what we've found that if you want to automate W3F, Spider-Man becomes a very, very big bottleneck, right? Because Spider-Man requires you to run a particular URL to stop. And for some reason, the API on Spider-Man doesn't work very well. So what we did was that the client had a QA team, right? A testing team that would test all these, their application on a regular basis. What we did was we put an MITM proxy in the QA environment. This MITM proxy would capture every single request and response that was going back and forth, and then log all of that into an Elasticsearch database. Once they were done with the QA, we would read these results using W3F's API and run a bunch of security tests on them. That way, you have a fully tooled and parameterized security test, a pen test that you're running with W3F. That really became a very powerful integration with W3F. So the first thing is the QA runs all the functional parameters are captured by the MITM proxy, and we're storing it as base64 requests and responses. We run W3F with the API, and of course, it gives us a great deal of results. And it gives you an authenticated scan result. So you're really doing it with all of that authenticated goodness and using W3F at the same time. So quick primer on W3F. W3F has all of this stuff in the scans resource. It has a REST API, so you call the scans resource, you get all the scans. You can get a particular scan ID and status. It will tell you whether the scan is running or it's stopped, whatnot. Of course, it will tell you that particular knowledge base of that scan ID, Val ID. It gives you even the traffic. It gives you all of that data related to that particular scan, that particular vulnerability. So you can just pull it as JSON, process it however you want. For custom application security stuff, when you need to really go after those logic flaws, we typically use Selenium when it's a web application. I also use another Python library called PyRestTest, which is pretty nice. It's a REST testing framework with YAML payloads. You can put in payloads in YAML. You can put in all of the necessary configurations for that particular test, and it's pretty good. It's pretty simple to use, and you can instrument this pretty nicely. Of course, all of this can be integrated with stuff like Jenkins. You can, with your CI/CD pipeline, you can integrate all of these tests. They can be called as tasks. Again, I don't have the time, but I can show it to you guys after the talk if you want. So the next story is the story on the threat model. Now, how many of you have threat models that are regularly updated? So usually what happens is that you start a project, you write a bunch of threat models, and that's it, right? You typically have that as a scenario. So recently I was dealing with a client in the e-learning space, and on January 1st, we had done a bunch of threat models. And And in May, they engaged us for a pen test. I said, can you show me your threat models? And they showed me the threat models on January 1st. I was like, okay, these are January 1st. By now, you have actually integrated 3 new different service providers to your portal. You have integrated a bunch of other stuff. You've integrated payments. Where is all that showing up? And they're like, hey, we did this. That's it. There's nothing more. So now, the way we do threat modeling is kind of dead because we're doing it in a waterfall model kind of a way. It's not really agile, in my opinion. The way we should be doing threat models is to use concepts of agile development. Like in Scrum, you have user stories. So create threat models that are abuser stories. Abuser stories are stories which indicate how your application could be compromised, why it could be compromised, what is the story behind that. And this can become a very, very important input to your entire agile development process. So typically, the abuser story essentially captures what happens when you have a particular or a potential for abuse of your product. What is the vulnerability you would use? Who would be the victim? What kind of difficulty of exploit, and all of that stuff would be captured. And of course, the great thing about this is that you can iteratively introduce it as part of each Scrum cycle or as part of each Scrum sprint. So you can integrate it into your product backlog, and every single time it could be consumed by that particular backlog at that given point in time. So iterative threat modeling obviously helps you out in security test cases extensively. Prioritization of bug fixes, obviously, it will help you a lot because you can really prioritize, okay, I am chasing authorization flaws today, or I am chasing these kind of flaws that could cause a serious repercussion on that particular sprint. So that would be a very, very serious issue. Creating security pipelines, obviously, you can link your entire security test case scenarios with your threat models, which would give a really powerful, not only a data point that you can showcase to management, but to your own developers. Say that this is very key to our management or to our product success, and this is what happens. So you can really bring about that whole story in a very powerful way. So typically you would have the threat profiles, which would be your theme or your epic, which would break down into abuser stories or threat models, integrated into your product backlog, your sprint backlog, and then of course you would have your countermeasures and test cases written for this entire thing on an iterative basis. Obviously, this is a very simple way of integrating threat models into your agile development practices. Now, the last story I'm going to be talking about pretty quickly is the fallacy around infrastructure as code, right? Now, infrastructure as code is great. All of us may have used stuff like Ansible, Chef, Puppet, Kubernetes, whatnot. Now, one of the things that I have noticed is that security kind of tends to get left out. We are so caught up in writing scripts and writing code for all this that we really don't think about security. And the worst part is that you're actually deploying vulnerabilities at scale. So let's say you have 100 servers and you're deploying IAC code, you're deploying vulnerable code to 100 servers at the same time. It's like a massive Control-C, Control-V problem, right, that you have. So that becomes a very, very serious issue. So of course, all the cool kids in the house are using Docker today. Everybody is Docker this, Docker that, container this, container that. But if you see some of the security issues that were identified on Docker over last year and even early this year, you can see that it's pretty staggering. A lot of the Docker container code, it contains vulnerable code. Stuff like Heartbleed and Shell Shock, which should have been long gone, are still found in a lot of our Docker containers. But of course, Docker is trying to address this using the security scanning. You have a bunch of tools like, I think Black Duck has a bunch of products. You also have Linus. I don't know how many of you use Linus, L-Y-N-I-S. Linus is a great product that can do security hardening on Linux, and it can also do a very good job of Docker security hardening. Of course, IAC is great, but when it comes to stuff like NoSQL and key-value databases like Mongo, for some reason, Mongo, we never find a good way to secure Mongo, right? It's always leaking data on there. Somehow, administrators always find a way to just keep Mongo running open and wide. And this has become a serious issue. People who use products like this, RabbitMQ, Memcached, I use these products, and I know that as soon as you install them, they install in a default vulnerable state. They expose an unnecessary bunch of ports, they expose an unnecessary bunch of services, and unless you really know what you're doing, these can really bite you in the back. So all of these technologies are great, especially MongoDB Elasticsearch, great piece of tech, but again, if you don't know how to lock it down, you can actually have people just run dynamic scripting on it and get shell on your box. So it's pretty serious stuff. Of course, the stack has gotten pretty complicated, and it's nobody to blame. Earlier, it was just a database, a web server, and an application server. Today, you have database, you have queuing systems, caching systems, you have key value stores, you have analytics stores, you have big data, you have whatnot. You have a ton of stuff that is becoming pretty complicated, which is why you have IAC, but IAC is still not solving the security problem. So today, it's really about the fact that security hardening is being associated with this, but IAC is code, so you can't really do hardening in the true sense, like have a document and say, this is a hardened server. Things change quite a lot, so you really need to adapt to the whole IAC paradigm. So how do we solve this? Actually, there are a lot of projects that are aiming to solve this. There is something called DevSec hardening set of scripts in GitHub, which is available here. It's pretty great. What I do and what we do as a team is whenever people write IAC code, we also have a post check, which is either a Nessus or an Nmap, which is actually performing a particular set of NSE scripts to validate whether these things have actually been fixed or not. So for instance, let's say you deploy a Mongo server. As soon as you deploy, the post-deploy script would be an Nmap script that would run a MongoDB-databases or a MongoDB-enum script, which would identify whether that particular Mongo instance is leaking any sensitive data or leaking or it's been misconfigured in some way. Of course, you can write a lot of other validations as well, but this is some of the things that you can do. Linus is a great product as well. It has an open source variant and it also has a paid variant, but again, that is really up to you guys if you want to use something like that. It's quite interesting. What we've also done is another project that we've started is to pull up data from different sources like Alien Vault, OTX, the NIST, NVDs, the CVE databases, correlate them using an Elasticsearch database and use that for security dependency checking and other security scanning, post-deployment, and so on and so forth. So that's pretty interesting. If anyone wants to talk about that post the talk, I'll be very happy to do that. So in conclusion, I hope I'm in time. I think DevOps and security can really play well together, even though there are articles claiming that DevOps and security can never do that. I really believe that it's all about changing the mindset. I think we are stuck in security in the pre-DevOps mindset where we do everything post things, but I think it needs to be in tandem, or it needs to be as part of it and as iterative as application delivery. Only then the fat guy can catch up with Usain Bolt, right? So that's the only way that's going to happen. We just need to fit the pieces and keep them continuously fitted as possible. So with that, I'd like to thank you for your time. Thank you for having me here. I hope you enjoyed the talk. Please feel free to have a discussion with me after this. I can also show you some of the work we've done if you want. Thank you very much. Any questions?
We have time for a few questions. Just remember to repeat the question so that it gets recorded together with you.
Sure.
Because we don't have a mic. Somebody has a question here? Yeah.
Sure. Mm-hmm.
And we see also scanning as
Okay.
how do you defend that things with a release cycle of 1 or 2 weeks, they scan, they do some automatic scanning, and then they go live. But how do you deal with that? Because there is a reason we do basically pen testing.
Okay. Yes, of course. Sure, sorry. So his question is that they have a similar set of problems. Some of them have application scanners, and while application scanners are great, how do you eliminate, or do you see the need to eliminate manual pen testing? Is that the question? Do you see the need to eliminate manual pen testing? Is that your question? Have I said it right? So obviously, my answer would never be to eliminate manual pen testing, because I think until we achieve true artificial intelligence, it's not possible to eliminate manual pen testing, because every application has complex set of flows and complex set of logic. So that's not possible. However, what you should be doing is, first of all, tooling the tools, the automated vulnerability scanners, extremely well. You need to push them to their limits. Just like any other tool, you need to take them to their limits. That's point number one. Try and give them as much steroid as possible. That is point number one. Point number two would be, you will need to take your manual pen testing and script it. So once you're done with the pen test, or as you're running a pen test, write scripts for that particular pen test. That's what we do. And those scripts need to be integrated into your CI or your CD pipeline. So every single time your product, so you would have like a database of manual pen test scripts up and running every time you have a release. So every release you would have your manual pen testing scripts that are constantly running, constantly working along with your automated scanners. So that gives you a much higher level of assurance. It still doesn't mean that you're 100% secure, which is not a possibility, but it does mean that you are really, you're getting a serious bang for your buck on that. Any other questions? This either means that people have understood it a lot or not understood it at all, right?
People are hungry.
I know. I think that's the more likely. Thank you very much. Thanks for your time.